Okay, perfect. So hi everyone, for those of you who I haven't met before, my name's Allison, and I'm on the Microsoft Edge layout team. Today I'll be discussing out-of-flow position fragmentation, some of the challenges that we face with that, and how we're addressing those different issues in LayoutNG. So some of you may already be familiar with fragmentation. You'll encounter it whenever you are printing a web page or when you're using multi-column layout. But I figured it'd be best to start out with a quick overview of some of the basic concepts. So we'll start off by defining a few important terms that you'll see throughout the CSS spec. The first of which is a fragmentainer. So fragmentainer is short for fragment container, and it's a box that holds a portion of the content that is fragmented. And you can think of fragmentainers as defining the boundaries where content breaks during fragmentation. Next up are fragmentation contexts, which are a collection of fragmentainers. And with those two definitions, we can now define what fragmentation is. So according to the spec, fragmentation is the process of splitting content across fragmentainers that form a fragmentation context. In other words, fragmentation is the process of breaking content between defined containers that are grouped together, forming one larger context. So there are various different types of fragmentation contexts, one example of which is pagination. You'll see this whenever you're printing the content of your web page. And in this case, when printing, the content breaks between pages with a set size. Therefore, in this case, each fragmentainer is the individual page, and the fragmentation context is the collection of those pages. Another common form of fragmentation that you'll see are multi-columns. And multi-columns are similar to how content is usually laid out in like a magazine or a newspaper. The content flows between a defined set of columns. So in this case, the fragmentainers are each individual column, and the contexts are the grouping of those columns. The third type of fragmentation context is regions, and regions aren't supported in Blink. However, you can think of regions as a customizable fragmentation format. And so as pictured here on the right, each blue box outlines each fragmentainer or region. And these customizable fragmentainers provide a lot more flexibility than you get with pages or multi-columns. So next up, let's define what a fragment is. So according to the spec, a fragment is the portion of a box that belongs to exactly one fragmentainer. So for example, if you have a div that fragments between two columns, each green box in this example would be a fragment of the original div. So another term that you'll hear when discussing fragmentation is monolithic. So monolithic content is content that isn't allowed to break. So for example, images and videos are considered monolithic since if you break, for example, a video, the content would become unusable. And so that wraps up the basic concepts of fragmentation. There's a bunch of information and rules that I left out, but I've included links to the various CSS specs in case anyone's interested in learning a bit more. So next up, let's take a look at how fragmentation works in LayoutNG. And for those of you who don't know, LayoutNG is the new Blink layout engine. So to demonstrate how fragmentation works in LayoutNG, I'll walk through a simple multi-column example. So let's say that you have a multi-column element with 3 columns, each with a height of 100 pixels. And let's also say that inside the multi-column, we have a child div with a height of 250 pixels. So we'll begin laying out the child in the first column, and when we hit the 100 pixel boundary, we need to fragment. So to handle fragmentation in LayoutNG, we create what's called a break token. And a break token is essentially the minimum information needed to continue layout in the next fragmentainer. It holds a bunch of information, but we'll focus on one of the main pieces of which is called the consumed block size. And this is essentially the total height we've laid out up to this point in time. So given that we've consumed 100 pixels so far of our 250 pixel total block size, we'll set this to 100. Another interesting piece of information that we store inside of our break token is a list of our child break tokens. So for example, if our div had a child nested inside of it but also fragmented, we would store a reference to the child break token in our own break token as well. However, to make things a bit simpler, let's pretend that we don't have any extra children. What happens next is that we'll pass this break token to the next column. And since we've consumed 100 pixels so far, we know that we have 150 pixels left. So we'll begin layout again, but we hit another boundary. So we need to create a new break token. And this time, we've consumed 200 pixels in block size, so we'll update the break token to reflect this. Similarly, we'll pass the break token to the third column, and based on our consumed block size, we know that we have 50 more pixels to lay out. And that's it. Our remaining 50 pixels fits comfortably inside the last column. We don't need to create any more break tokens, and we've finished layout. So before we can talk about fragmentation of out-of-flow position elements, let's quickly review what an out-of-flow position element is. So when we talk about out-of-flow position elements, we're talking about elements that are fixed or absolute positioned. But we'll focus on absolute position elements for the purposes of this presentation. So an absolute position element is an element that's taken out of the normal flow of layout and positioned relative to its containing block. In other words, it's positioned relative to its nearest position ancestor. For example, in the following case, the containing block of our absolute position element would be its relative position ancestor. Next up, how do we handle layout of out-of-flow position elements in general, excluding any fragmentation? So layout happens in a recursive manner. So for example, in this case, if we're going to lay out the relative position element, we would recurse down a tree until we've reached the innermost child. In this case, that child happens to be an absolute position element. And in order to perform layout on this element, we need to wait for its containing block to finish layout first. And since our containing block hasn't finished layout yet, we'll create what's called an NG out-of-flow position node. I'll discuss a bit more about what we store inside this data structure in a later slide, but it's essentially the minimum information needed to perform layout on an out-of-flow node once we've reached its containing block. So once we've created that node, we can perform layout on its parent. So we haven't reached the containing block yet, so we need to propagate the node up the tree further. And at this point, we have reached the containing block, so we can perform layout on the absolute position descendant. So an out-of-flow position node, as I mentioned, is what we pass up the tree to perform layout of an out-of-flow element at a later point in time. Inside this class, we store the out-of-flow element's block node, and we also store the element's static position. And the static position is the offset the out-of-flow element would have had it been inflow and not taken out of flow. And with these two pieces of information, we can perform layout at the containing block. So with that, we've concluded the overview of out-of-flow position elements and an overview of what fragmentation is. So now let's talk about how we actually fragment these out-of-flow position nodes. So to illustrate this, let's take a look at the same out-of-flow position example. If you recall, we wait to lay out any absolutely positioned element until we've reached the containing block. So if we were to add a multi-column to this example, we would no longer be able to perform layout of the out-of-flow position element once we've reached the containing block as we had before. And the reason being that the containing block may have broken and may not have finished layout by the time we encounter the absolute position element. So to address this, we need to bubble up any out-of-flow position elements to the fragmentation context root instead. And after the multi-column in this example is finished layout, we can go ahead and lay out the out-of-flow position element as well. So this leads us to the first step of our four-step algorithm, and the first step of which is that we bubble up the out-of-flow nodes to its fragmentation context root. This actually leads us into our next issue. So because we're performing layout at a later point in time, we no longer know what our containing block is or where that containing block is located. And these two pieces of information are needed in order to position our element correctly. So to address this, we need to collect extra information inside the out-of-flow position node as a part of our first step. So as you may recall, we currently store the block node and static position of our autofill element inside the autofill position node. However, this information is no longer sufficient when performing layout at the fragmentation context root. So we need to actually collect two extra pieces of information. We need to store the physical fragment of our containing block. That way we know what element we should be positioned against. Additionally, we need to store the offset of the containing block to the start of the fragmentation context root. So to illustrate the information stored inside the autofill position node a bit further, let's take a look at an example. So if we have a multi-column, and inside of that we have a relative position element that's outlined here in red, starting in the second column and breaking into the third. Now let's also say that we encountered an absolute position element in the third column, represented here by this anchor. So the first piece of information that we store inside the autofill position node is the block node of the absolute position element that we encountered. Next, we stored static position, which is the position it would have had it been laid out in flow. And so in this example, this would be the block height from the anchor to its containing block. Next, we store a reference to the physical fragment of the containing block that we found the autofill element inside of. And this would be the fragmented red box in the third column. Finally, we also store the offset of the containing block relative to the fragmentation context root. In this case, that offset spans from the top of the first column to the start of the containing block in the second column. And so now that we have all that information and all the information needed to perform layout at the fragmentation context root, we can finally lay out the autoflow node. And so the goal of layout in general is to determine the position and size of any given element. And so the first part of this, what we'll need to do is determine the offset to begin layout. So for example, let's say that we have our same use case as before, but we want to position the absolute position element at a top of 0. With a top of 0, that means that we want to position the element such that it starts at the beginning of its containing block. So given that we know the offset of the containing block, we also know where the offset of the absolute position element should be in this case. So given that we now know our start offset, we can now determine which fragmentator we'll begin layout in. So in our previous example, based on our start offset, we know that we would start layout in the second column or second fragmentator. Next up, we'll create our constraint space. And so a constraint space is the available space that we have for layout. And in the case of autoflow fragmentation, our constraint space will be based on our containing block in the inline direction, which we stored in our autoflow position node, and based on our fragmentator, which we just calculated, in the block direction. So with that, we can finally call our layout function, which will give us back a layout result. And with that layout result, we'll have to handle any break tokens that we produced. So more specifically, if you recall, if our layout result produced a break token, we know that we fragmented. So this means we need to continue layout in the next fragmentator. So once we determine the fragmentator that we'll start layout in next, we can create a new constraint space. And with that, we can perform layout again, repeating all of these steps until we've produced no further break tokens. And at which point, we know that we've finished layout. So once we've finished layout and have produced all our fragments of the absolute position element, we need to add those fragments as children to their corresponding fragmentators. Which leads us into our third issue. So we want to add the autoflow fragments to existing fragmentators. However, these fragmentators have already finished layout and are considered immutable at that point. And that means that we can't actually add any new information to them. So to address this, we need to create a copy of our fragmentators. And once we've created a copy, we can add the autoflow fragments as children to the cloned fragmentators. Finally, the last step of our algorithm is to add any new fragmentators if it's needed. So to illustrate this, let's say that in our example, the obsolete position element extended beyond the last existing fragmentainer. In this case, we'd need to create a new fourth fragmentainer to hold this content. And with that, we've added support for autoflow position element, fragmentation, and you just need these 4 steps. So we've actually completed the basic implementation of that algorithm, of course with some remaining bugs to take a look into. However, there are a few other interesting cases that still need to be handled as a part of this project. So to illustrate one of the scenarios that is currently being worked on, we'll take a look at what I'll call height auto bottom 0. So let's say that we have a multi-column with height 100 pixels, and inside that we have a relative position element that has a height of 250 pixels and is outlined here in red. Finally, now let's say that we have an absolute position element nested inside of the relative position element, and let's say that we set its bottom to 0. So at the bottom of 0, that means we want to have it positioned such that it ends layout at the bottom of its containing block. We've also set its height to auto, which means that its height is dependent on its content. So we know where we want the content to end, but without knowing how tall the absolute position element will be, we don't actually know where to start layout. So to handle this case, before we officially lay out the absolute position element, we first need to run a non-fragmented layout pass. And this will give us the height of our absolute position element, which will tell us where we should start layout. At which point, we can perform layout as usual, allowing for any fragmentation. So we'll need at least 2 layout passes for this example. So another case that hasn't been addressed quite yet is nested fragmentation. And nested fragmentation is when you have at least one fragmentation context nested inside of another. So for example, if you're printing a multi-column, or if you have one multi-column nested inside of another one. So to illustrate this, let's take a look at our original multi-column example. If we add an outer multi-column to this example, we would have created a nested fragmentation context. So in this case, we can no longer perform layout of the autoflow node once we've reached the inner multi-column as we had previously. And the reason being that the inner multi-column may have broken as a result of the outer multi-column, and thus we cannot ensure that its containing block has finished layout at this point. Instead, we need to bubble up the autoflow position nodes to the outer multi-column, at which point we know that the containing block has finished layout, so we can determine the correct position and lay out the autoflow node. So in order to lay out the autoflow position elements at the outer fragmentainer, we need to store some extra information about its inner fragmentation context root in order to fragment correctly. So we have a generally good idea of what needs to happen here, but the design is still somewhat in the works. However, handling this case will be the next big step in finalizing fragmentation support for autoflow elements. So before I conclude the presentation, I wanted to acknowledge that this has been a larger group effort. So I want to give a quick shout out to the rest of the folks who've contributed thus far to this project. And with that, I'll open the floor for any questions. I think I saw a hand raised.
Oh, yeah. How is the cross-browser compatibility with this?
That's a good question. I think it matches really closely to Edge HTML, which but I think Firefox does something. I'm not sure what Firefox does, but I think in most cases this does match up pretty well. Any other questions? Or I guess we can always conclude early.
By match up pretty well, do you mean WebKit?
Yeah, like
a lot of these cases correctly?
yeah, so basically just like making sure that the various test cases that we're running against are working in the various different browsers in the same way. So yeah, in general, I think the test cases that at least that I've been testing against match pretty well with the other browsers.
I think broadly speaking, though, this will be a significant improvement on our behavior that we had previously. However, like if you take the bottom zero height auto case, there was sort of not really a way to get that correct before, and not fragment like between a line, for example, or on a line rather.
But since Blink and WebKit share that ancestry, it's probably still broken in WebKit, right?
Yep.
Okay.
Yeah, this behavior should be much much nicer. It'll also mean that things like paint effects around outer flows should appear nicer. Like if you've got a blur on an outer flow that's fragmented. Today, I don't think that works too well.
Got it. Okay.
How about the inline containing block that's an inline?
Yeah, so this was mostly regarding like block fragmentation. Inlines are handled slightly differently, and we're not doing anything special for like out of flow elements in that case. But yeah, this was mostly focusing on block fragmentation.
But inlines can be containing block for out of flow elements. If you have a position relative on a span, it becomes a containing block for an out of flow.
Yeah, I don't know that we've looked into that case yet, so I can definitely test it out. But I don't think we need to do anything particularly special for that.
I wrote the original out of flow code for NG.
Okay.
So handling that is a little bit of a tricky thing.
Yeah, no, I can definitely take a look at that one.
Oh, great. I'm so glad that you're doing this, because it seems like a tough project.
Yeah, no, it's definitely been had its challenges, but it's been a good learning opportunity, so it's been a lot of fun.
Oh, awesome.
I think to sort of put this in slightly more broader context, I'd sort of place this as the one of the hardest problems involved in fragmentation. And like fragmentation itself is one of the hardest topic in terms of like layout. So this is sort of coming in advanced mode. So the work here has been super impressive.
And I appreciate all the help that we've gotten from your guys' side as well. It's been a great learning opportunity, so I appreciate it.
Yeah, handling out of flow inlines. Handling inline containing block has probably been the worst compatibility between browsers I've ever seen. Like nobody does anything even remotely reasonable before NG.
Yeah, I can imagine. Well, cool. I think we have 1 minute left. If there's any other questions, we could wrap up early. Okay, cool. Well, I guess we can end there. Thanks everyone for joining. If there's any other questions, feel free to reach out to me on Slack or email. Definitely open to answering any other questions. So thanks again.